Question 1. The analysis reveals that a critical business rule in an oracle9i forms application requires that if a customer's credit limit is updated, all their outstanding invoices must be immediately re-evaluated to ensure they do not exceed the new credit limit. If any invoice would exceed the new limit, the update to the credit limit should be prevented, which approach best upholds data integrity and application maintainability within the specified oracle9i forms development framework. Option A. Modify the form's application's post-update trigger to iterate through all outstanding invoices for the customer and perform the validation. If validation fails, the post-update trigger will attempt to roll back the credit limit update. Option B. Implement client-side validation within the Oracle Forms application, using when validate item or post-change triggers on the credit limit field. This logic will fetch all outstanding invoices and check them against the new credit limit before allowing the update. Option C. Implement a database trigger on the customer table that fires before update on the credit limit column. This trigger will query the outstanding invoices for the customer, and if any invoice total exceeds the new credit limit, will raise an exception to prevent the update. Option D. Rely on manual review by accounting staff to identify and correct any invoices that exceed the new credit limit after the credit limit has been updated. The correct answer is C. Implement a database trigger on the customer table that fires before update on the credit limit column. This trigger will query the outstanding invoices for the customer, and if any invoice total exceeds the new credit limit, will raise an exception to prevent the update. Explanation. The analysis reveals a common challenge in Internet application development, ensuring data integrity and security within the constraints of oracle9i forms and its associated database. The scenario presents a developer needing to implement a critical business rule that impacts multiple records. The professional challenge lies in balancing the need for immediate data consistency with the performance implications of complex database operations, all while adhering to the principles of robust application design and data management, as expected within the oracle9i forms development context. Careful judgment is required to select an approach that is both technically sound and aligns with best practices for application development and data integrity. The correct approach represents best professional practice because it leverages the declarative features of Oracle Forms and the power of SQL to enforce data integrity at the database level. By using a database trigger, the business rule is enforced consistently, regardless of how the data is modified, e.g., through Forms, SQL*+, or other applications. This ensures that the data remains in a valid state at all times, which is a fundamental principle of data management and application reliability. This approach minimizes the risk of data corruption and simplifies application logic by offloading enforcement to the database, which is the most reliable place for such rules. This aligns with the principles of building robust Internet applications, where data consistency is paramount. An incorrect approach that relies solely on client-side validation within Oracle Forms is professionally unacceptable. This is because client-side validation is easily bypassed. A malicious user or even an accidental error in another client application could modify data without triggering the forms-based validation, leading to data inconsistencies and potential security vulnerabilities. This violates the principle of robust data integrity and security, as critical business rules are not reliably enforced. Another incorrect approach that involves complex procedural logic within the form's triggers, e.g., fetching and updating multiple records within a when-validate item or post-change trigger, is also professionally problematic. While it might appear to enforce the rule, it can lead to performance issues, especially with large datasets. Furthermore, it creates tightly coupled application logic that is difficult to maintain and test. If the business rule changes, multiple forms triggers might need modification, increasing the risk of errors and inconsistencies. This approach also fails to guarantee integrity if data is modified outside of the form's application. The professional reasoning process for similar situations should involve a systematic evaluation of where business rules are best enforced. The primary consideration should be the database itself as the ultimate source of truth and the most reliable place for enforcing data integrity. Developers should then consider the declarative features of the development tool, Oracle Forms in this case, for user interface level validation and user experience enhancements. Procedural logic should be reserved for complex application-specific behaviors that cannot be handled by declarative means or database constraints. And even then, it should be implemented with performance and maintainability in mind. A layered approach, starting with database-level enforcement, followed by application-level enforcement where necessary, is the most robust and professional strategy. Question 2. The efficiency study reveals that the oracle9i Forms Internet application is experiencing significant slowdowns during peak usage, impacting user experience. As an oracle9i Forms developer, what is the most effective strategy to address these performance bottlenecks within the existing application framework? Option A. Implement client-side JavaScript to handle data manipulation after fetching all data from the database. Option B. Increase the database server's hardware resources to accommodate the increased load. Option C. Analyze and refactor PL/SQL code blocks to optimize database queries, reduce round trips, and implement efficient data fetching techniques. Option D. Rewrite the entire application using a modern web development framework without a detailed analysis of the existing oracle9i Forms code. The correct answer is C. Analyze and refactor PL/SQL code blocks to optimize database queries, reduce round trips, and implement efficient data fetching techniques. Explanation. The efficiency study reveals that the current Oracle Forms application, built using oracle9i Forms Developer, is experiencing significant performance degradation during peak user loads. This is impacting user productivity and potentially customer satisfaction. The challenge lies in identifying the root cause of this performance issue within the application's architecture and code, specifically concerning how data is fetched and processed, without introducing new architectural complexities or violating the principles of efficient Internet application development as understood within the context of oracle9i Forms. The chosen solution must be implementable within the existing oracle9i Forms environment and adhere to best practices for building Internet applications at that time, focusing on optimizing database interactions and client-server communication. The correct approach focuses on optimizing the data retrieval mechanisms within the Oracle Forms application. This involves analyzing and refactoring PL/SQL code blocks, particularly those responsible for fetching large datasets or performing complex calculations. Strategies such as reducing the number of database round trips, utilizing efficient SQL queries, e.g., avoiding select asterisk, using appropriate where clauses, and considering index columns, and implementing judicious use of array fetching or block fetching where applicable, directly address the performance bottlenecks. This aligns with the principles of building efficient Internet applications by minimizing network latency and database load, which were critical considerations for oracle9i Forms applications deployed over a network. Adhering to these principles ensures that the application remains responsive and scalable within the constraints of the oracle9i Forms technology. An incorrect approach would be to implement client-side JavaScript for data manipulation after fetching all data from the database. While JavaScript is a powerful tool for web applications, its integration with oracle9i Forms for significant data processing after retrieval would introduce substantial complexity, potentially lead to inconsistent behavior across different browsers, and bypass the optimized data handling capabilities of the Oracle Forms client and database. This approach fails to address the core issue of inefficient data fetching from the database, and instead shifts the burden to the client in a manner not natively supported or recommended for performance optimization within the oracle9i Forms paradigm. It also introduces a dependency on client-side scripting that might not be uniformly supported or managed, leading to potential instability. Another incorrect approach would be to rewrite the entire application in a newer web technology without a thorough analysis of the existing oracle9i Forms application's strengths and weaknesses. While a complete rewrite might offer long-term benefits, it is a significant undertaking that goes beyond addressing the immediate performance issues. It also ignores the potential for optimizing the existing oracle9i Forms application, which is the direct subject of the efficiency study. This approach represents a failure to perform a targeted diagnostic and remediation, instead opting for a drastic and potentially unnecessary solution that carries its own risks and costs. It does not demonstrate professional judgment in addressing the specific problem identified, A third incorrect approach would be to simply increase the database server's hardware resources without investigating the application's code. While more powerful hardware can sometimes mask performance issues, it does not resolve the underlying inefficiencies in the application's logic. This is akin to treating a symptom rather than the cause. It is a costly and unsustainable solution that fails to leverage the developer's expertise in optimizing the application itself. Professionally, this approach demonstrates a lack of due diligence in identifying and rectifying application-level performance bottlenecks, which are often the primary drivers of slow performance in database-driven applications. The professional decision-making process for similar situations involves a systematic approach. First, clearly define the problem and its impact. Second, gather data and analyze the current system's performance characteristics. Third, identify potential root causes based on the technology stack and application architecture. Fourth, evaluate various solutions, considering their feasibility, cost, and impact on the existing system. Fifth, select the most appropriate solution that directly addresses the root cause while adhering to best practices and constraints. And finally, implement, test, and monitor the solution to ensure its effectiveness. Question 3. The risk matrix shows a high likelihood of user input errors for customer account numbers due to their complex alphanumeric format. As an Oracle Forms9i developer building internet applications, which approach best mitigates this risk while adhering to best practices for the platform? Option A. Omit explicit validation within the Forms application and establish a manual data correction process to rectify invalid account numbers post-entry. Option B. Rely solely on database-level check constraints to validate the format of the customer account number after the record has been submitted from the Forms application. Option C. Implement validation logic within Oracle Forms using whenValidateItem triggers and PL/SQL to check the format and structure of the account number before it is submitted to the database. Option D. Integrate external JavaScript validation routines directly into the Forms client to enforce the account number format. The correct answer is C. Implement validation logic within Oracle Forms using whenValidateItem triggers and PL/SQL to check the format and structure of the account number before it is submitted to the database. Explanation. The scenario presents a common challenge for Oracle Forms developers, managing user input validation to ensure data integrity and adherence to business rules, particularly when dealing with potentially sensitive or complex data types. The challenge lies in balancing user experience, providing immediate feedback, with robust validation that prevents erroneous data from reaching the database, all within the constraints of the Oracle Forms9i environment and its built-in functionalities. The correct approach, leveraging Oracle Forms built-in validation triggers, like whenValidateItem or whenValidateRecord, and PL/SQL code, represents best professional practice because it directly addresses the exam's focus on building internet applications with Oracle Forms9i. This method ensures that validation logic is executed at the client side, Forms client, before data is submitted to the database, providing immediate feedback to the user and reducing the load on the database. It aligns with the principles of efficient application development by utilizing the tools provided by the Oracle Forms environment. Furthermore, it adheres to the implicit regulatory expectation of data integrity and accuracy in any application, ensuring that the data stored is reliable and meets defined business requirements. An incorrect approach that relies solely on database constraints, like check constraints or triggers, for validation fails to provide timely user feedback. While database constraints are crucial for enforcing data integrity at the database level, they only report errors after the data has been submitted from the Forms application. This leads to a poor user experience, as users may not understand why their input was rejected until after submission, potentially leading to frustration and rework. From a professional standpoint, this approach neglects the user interface aspect of application development, which is a core component of building effective internet applications. Another incorrect approach, attempting to implement complex validation logic directly within the Forms client using JavaScript or other client-side scripting languages not natively supported or integrated with Oracle Forms9i, would be professionally unsound. Oracle Forms9i's architecture is primarily based on PL/SQL for business logic and validation. Introducing external scripting without proper integration mechanisms would lead to maintenance nightmares, compatibility issues, and a departure from the established development paradigm for the platform. This would violate the principle of using the appropriate tools and technologies for the given environment, potentially leading to unstable applications and increased development costs. A third incorrect approach, ignoring validation entirely and relying on manual data correction processes after data entry, is fundamentally flawed and professionally unacceptable. This approach directly compromises data integrity, leading to inaccurate reporting, flawed business decisions, and potential compliance issues depending on the nature of the data. It represents a failure to implement basic application quality controls and demonstrates a lack of understanding of the importance of data accuracy in business applications. The professional decision-making process for such situations involves a layered approach to validation. First, leverage the Oracle Forms environment's built-in triggers and PL/SQL for client-side validation to provide immediate user feedback and catch common errors. Second, implement robust database constraints to act as a final safeguard for data integrity at the database level. This ensures that even if client-side validation is bypassed or fails, the database will still enforce the rules. Finally, consider the specific business requirements and the sensitivity of the data to determine if additional, more complex validation logic is necessary, always prioritizing solutions that are well integrated with the Oracle Forms 9i architecture. Question 4. During the evaluation of a new feature for an internet application that allows users to input and display personal financial details, a developer identifies that client-side JavaScript can be used to validate the format of these details before submission. However, the developer also recognizes that client-side validation can be bypassed. The developer must decide on the most secure method for ensuring the integrity and confidentiality of this sensitive financial data. Option A. Rely solely on client-side JavaScript validation to ensure the correct format of the financial details before they are processed. Option B. Store the financial details directly in client-side variables without any encryption, assuming the user is trustworthy. Option C. Implement robust server-side validation for all financial data submitted by the user, in addition to any client-side validation. Option D. Proceed with the feature implementation without any validation, as the primary goal is to provide a responsive user experience. The correct answer is C. Implement robust server-side validation for all financial data submitted by the user, in addition to any client-side validation. Explanation. This scenario presents a professional challenge because the developer is tasked with implementing a feature that, while seemingly functional, carries a significant risk of exposing sensitive user data if not handled with extreme care and adherence to established security principles. The core of the challenge lies in balancing the desire for a dynamic and responsive user interface with the imperative to protect confidential information. The developer must make a judgment call that prioritizes data security over immediate functional convenience, a common tension in application development. The correct approach represents best professional practice because it directly addresses the potential security vulnerability by implementing a robust server-side validation mechanism. This aligns with the principle of defense in depth and the security best practice of never trusting client-side input. By performing validation on the server, the application ensures that even if client-side scripts are bypassed or manipulated, the integrity and confidentiality of the data remain protected. This approach is ethically sound as it upholds the developer's responsibility to protect user data and legally compliant by adhering to general data protection principles inherent in responsible software development, even without specific regulatory mandates for this exam's context. An incorrect approach that relies solely on client-side validation is professionally unacceptable because it creates a significant security loophole. Client-side scripts are easily manipulated by malicious users, rendering the validation ineffective. This failure to implement adequate security measures constitutes a breach of professional duty to protect user data and could lead to data breaches, reputational damage, and potential legal repercussions if specific data protection laws were applicable. Another incorrect approach, which involves storing sensitive data directly in client-side variables without encryption, is even more egregious. This is a fundamental security misstep that directly exposes confidential information to unauthorized access and manipulation, violating basic principles of data security and professional responsibility. A third incorrect approach, which ignores the validation requirement altogether and proceeds with the feature implementation, demonstrates a severe lack of due diligence and a disregard for potential security risks, making it professionally negligent. Professionals should employ a decision-making framework that prioritizes security and data integrity. This involves 1. Identifying potential risks and vulnerabilities associated with a feature. 2. Evaluating the impact of these risks on users and the organization. 3. Researching and applying established security best practices and relevant technical guidelines. 4. Implementing controls that mitigate identified risks, favoring server-side validation and secure data handling over client-side reliance. 5. Thoroughly testing the implementation to ensure security measures are effective. Question 5. Compliance review shows that the oracle9i Forms developer is building an internet application that handles sensitive customer financial data. The developer is considering different methods for protecting this data within the application's database. Which of the following approaches best adheres to the principles of data protection and secure development practices for internet applications? Option A. Implement security measures only at the application layer, such as input validation and session management, without applying any specific encryption or access controls directly to the sensitive data fields in the database. Option B. Encrypt sensitive financial data at the database level using Oracle's built-in encryption functions and implement strict access controls to the database tables containing this data. Option C. Store sensitive financial data in plain text within the application's database tables, relying solely on the application's user authentication and authorization mechanisms for protection. Option D. Avoid implementing any specific security measures for the sensitive financial data fields, assuming that the overall network security will adequately protect the data. Correct answer is B. Encrypt sensitive financial data at the database level using Oracle's built-in encryption functions and implement strict access controls to the database tables containing this data. Explanation. This scenario presents a professional challenge related to data security and privacy within the context of building internet applications using oracle9i Forms developer. The core issue is balancing the need to provide functional application features with the imperative to protect sensitive user data, as mandated by relevant regulations. The challenge lies in interpreting and applying these regulations to specific development practices, ensuring that data handling is both compliant and secure. The correct approach represents best professional practice because it prioritizes a proactive and comprehensive security strategy. By implementing robust data encryption and access control mechanisms at the database level, the developer directly addresses the regulatory requirement to safeguard sensitive information. This aligns with the principle of security by design, where security considerations are integrated from the outset of the development lifecycle, rather than being an afterthought. This approach minimizes the risk of data breaches and unauthorized access, thereby upholding user trust and adhering to legal obligations. An incorrect approach that involves storing sensitive data in plain text within the application's database tables is a significant regulatory and ethical failure. This directly violates data protection principles, as it leaves sensitive information vulnerable to unauthorized disclosure, even if the application itself has some internal security measures. Such a practice would likely contravene regulations that mandate the protection of personal data, leading to potential legal penalties, reputational damage, and loss of customer confidence. Another incorrect approach, which relies solely on application-level security measures without database-level encryption, is also professionally unacceptable. While application-level controls are important, they are often insufficient on their own. If the database itself is compromised, or if direct database access is gained through other means, the sensitive data would be exposed. This demonstrates a failure to implement defense-in-depth security, a fundamental best practice in data protection. A third incorrect approach, which involves neglecting to implement any specific security measures for sensitive data fields, represents a gross disregard for regulatory requirements and ethical responsibilities. This passive stance on data security is a direct invitation to data breaches and noncompliance, exposing the organization to severe legal and financial repercussions. Professionals should employ a decision-making framework that begins with a thorough understanding of applicable data protection regulations. This involves identifying what constitutes sensitive data within the application scope and understanding the specific requirements for its handling, storage, and transmission. The next step is to evaluate development tools and techniques, such as oracle9i Forms Developer, for their capabilities in implementing security controls. A risk-based approach is crucial, where potential threats and vulnerabilities are assessed, and security measures are prioritized accordingly. This framework emphasizes a proactive, layered security strategy that integrates technical controls with ongoing monitoring and auditing to ensure sustained compliance and data integrity. Question 6. Compliance review shows that the oracle9i Forms application being developed to manage customer orders stores customer addresses and payment card information directly in plain text within the database. The application uses basic HTTP for all data transmission between the client and the server. Which of the following represents the most appropriate and compliant approach to address these findings? Option A. Rely on the existing database security measures and assume that network firewalls will adequately protect the data during transmission. Option B. Remove all sensitive customer data fields from the database and instruct users to provide this information verbally during order placement. Option C. Implement encryption for sensitive data fields stored in the database and configure the application to use HTTPS for all client-server communication. Option D. Update the application to only store customer names and order details, and advise customers to use a separate, secure portal for payment information. Correct answer is C. Implement encryption for sensitive data fields stored in the database and configure the application to use HTTPS for all client-server communication. Explanation. This scenario presents a professional challenge related to data security and privacy within the context of developing Internet applications using oracle9i Forms. The core issue is balancing the need for application functionality with the imperative to protect sensitive user data, a critical aspect of compliance with data protection regulations. The challenge lies in identifying and implementing appropriate security measures without compromising the usability or performance of the application. The correct approach involves a thorough understanding of the data being handled, its sensitivity, and the potential risks associated with its exposure. Implementing robust security measures, such as encryption for sensitive data at rest and in transit, access controls, and secure coding practices, directly addresses these risks. This aligns with the principles of data minimization and security by design, which are fundamental to responsible data handling and are implicitly expected within the regulatory framework governing Internet applications and data privacy. Adhering to these practices ensures that the application is developed in a manner that is both functional and compliant, safeguarding user trust and avoiding potential legal repercussions. An incorrect approach that fails to implement encryption for sensitive data, such as personally identifiable information, PI, or financial details, represents a significant regulatory and ethical failure. This oversight exposes users to the risk of data breaches, violating their privacy rights and potentially contravening data protection laws. Another incorrect approach, such as relying solely on basic password authentication without considering more advanced security protocols like Secure Socket Layer, SSL, for data transmission, leaves data vulnerable during transit. This is a failure to implement adequate security measures for data in transit, which is a common requirement in data protection regulations. Finally, an approach that prioritizes feature development over security testing and vulnerability assessment is ethically unsound and professionally negligent. This can lead to the deployment of applications with exploitable weaknesses, directly endangering user data and the organization's reputation. Professionals should employ a risk-based decision-making framework. This involves identifying the types of data handled by the application, assessing the potential threats and vulnerabilities, and then selecting and implementing appropriate security controls to mitigate those risks. This framework emphasizes a proactive and systematic approach to security, ensuring that compliance is integrated into the development lifecycle rather than being an afterthought. It requires continuous evaluation and adaptation of security measures as threats evolve and regulations change. Question 7. Regulatory review indicates that an Oracle Forms application, deployed over the Internet, is responsible for collecting and processing sensitive customer information. A key requirement is to prevent the injection of malicious code or invalid data through user input fields. Which of the following development strategies best adheres to secure Internet application development principles for this scenario? Option A. Rely exclusively on client-side JavaScript validation embedded within the HTML generated by Oracle Forms to ensure data integrity and security. Option B. Delegate all data validation and security checks to the web server's configuration, without any specific application-level validation within the form's code. Option C. Implement comprehensive data validation and sanitization routines directly within the Oracle Forms server-side triggers and program units before data is processed or stored. Option D. Assume that database-level constraints, e.g., not null check constraints, will inherently protect the application from all forms of malicious input. The correct answer is C. Implement comprehensive data validation and sanitization routines directly within the Oracle Forms server-side triggers and program units before data is processed or stored. Explanation. This scenario presents a professional challenge related to data integrity and application security within the context of Oracle Forms development, specifically concerning the handling of sensitive user input. The core issue is ensuring that data submitted through a web-deployed Oracle Forms application is validated and protected against common web vulnerabilities, aligning with the principles of secure coding practices expected in Internet application development. The challenge lies in balancing user experience with robust security measures, ensuring that the application is both functional and resilient to malicious attacks. The correct approach emphasizes implementing server-side validation within the Oracle Forms application itself. This is best professional practice because it provides a critical layer of security that cannot be bypassed by the client. By validating data on the server, developers ensure that even if client-side validation is circumvented or disabled, the application will reject invalid or malicious input before it can affect the database or application logic. This aligns with the fundamental security principle of never trust client input. Oracle Forms, when deployed over the web, still operates with server-side logic that can and should enforce data integrity and security. An incorrect approach would be to rely solely on client-side validation, e.g., using JavaScript within the HTML generated by Forms. This is professionally unacceptable because client-side validation can be easily bypassed by attackers who can manipulate the HTML or JavaScript before it reaches the server. Another incorrect approach would be to assume that the database constraints alone are sufficient for security. While database constraints are vital for data integrity, they are a last line of defense and do not prevent malicious attempts to exploit application logic or inject harmful data through the application interface. Relying solely on database constraints leaves the application vulnerable to attacks that might not directly violate a constraint but could still compromise the application's integrity or expose sensitive information. Professionals should employ a defense-in-depth strategy. This involves multiple layers of security. For Oracle Forms Internet applications, this means 1. Understanding the security implications of web deployment. 2. Implementing robust server-side validation within the form's triggers and logic. 3. Leveraging database constraints for data integrity. 4. Considering additional security measures at the web server or network level if applicable. The decision-making process should prioritize security at the earliest possible point of data processing, which is the server-side logic of the Oracle Forms application. Question 8. Strategic planning requires a developer to implement a new data validation rule for user registration in an oracle9i forma application. This rule is critical for ensuring data accuracy and preventing fraudulent entries. The developer has identified two potential implementation strategies: a quick, direct integration into the existing form logic, or a more robust, multi-layered approach involving server-side validation and a separate validation module. Given the tight project deadline, which approach should the developer prioritize to ensure both functionality and system integrity? Option A. Prioritize the multi-layered approach with server-side validation and a separate module, even if it requires additional development time, to ensure robust data integrity and security. Option B. Implement the validation rule directly into the existing form logic for immediate deployment, as the deadline is the most critical factor. Option C. Rely solely on client-side JavaScript validation within the HTML form to provide immediate user feedback and meet the deadline. Option D. Defer the implementation of this validation rule to a later phase of the project to avoid impacting the current deadline. The correct answer is A. Prioritize the multi-layered approach with server-side validation and a separate module, even if it requires additional development time, to ensure robust data integrity and security. Explanation: this scenario presents a common challenge in Internet application development, balancing the need for rapid feature deployment with the imperative to maintain data integrity and security, especially when dealing with sensitive user information. The professional challenge lies in making a judgment call that prioritizes long-term system stability and compliance over immediate, albeit desirable, functional enhancements. Careful consideration of the potential downstream impacts of a hasty decision is paramount. The correct approach represents best professional practice because it adheres to the fundamental principles of robust software development and data governance. By prioritizing the thorough testing and validation of the new data validation logic before deployment, the developer ensures that the application remains reliable and that user data is protected from potential corruption or unauthorized access. This proactive stance aligns with the implicit regulatory expectation of due diligence in application development, even if specific oracle9i forma developer regulations are not explicitly detailed in a separate document. The focus is on building a secure and dependable system, which is a cornerstone of professional responsibility in software engineering. An incorrect approach that bypasses thorough testing of the data validation logic would represent a significant regulatory and ethical failure. It introduces an unacceptable risk of data integrity issues, which could lead to incorrect reporting, user dissatisfaction, and potential legal ramifications if sensitive data is compromised. Furthermore, deploying untested code, especially concerning data handling, demonstrates a disregard for professional standards and a failure to uphold the duty of care owed to users and the organization. This could be seen as a breach of implicit professional conduct guidelines that emphasize quality and reliability. Another incorrect approach, such as implementing the validation logic directly in the client-side HTML without server-side validation, would also be professionally unacceptable. While client-side validation offers a better user experience by providing immediate feedback, it is easily bypassed by malicious users or can be unreliable due to browser inconsistencies. This leaves the application vulnerable to invalid data submission, undermining data integrity and security. It fails to meet the professional standard of robust validation, which requires server-side enforcement. The professional decision-making process for similar situations should involve a risk-based assessment. Developers must first identify the potential risks associated with each proposed solution, considering factors like data security, integrity, performance, and user experience. They should then evaluate these risks against the benefits of each approach, always prioritizing solutions that minimize harm and maximize long-term system health. Consulting with stakeholders, including project managers and potentially legal or compliance officers, can provide valuable perspectives and ensure alignment with organizational policies and any applicable, even if implicit, regulatory expectations. The ultimate decision should be documented, along with the rationale, to provide an audit trail. Question 9. The efficiency study reveals that the oracle9i Forms application, responsible for processing high volumes of customer orders, is experiencing unacceptable response times during peak operational periods. This performance degradation is leading to increased customer complaints and potential revenue loss. As a developer tasked with addressing this issue, which of the following strategies would be the most professionally sound and effective in diagnosing and resolving the performance bottlenecks? Option A. Immediately upgrade the database server hardware and increase the application server memory allocation, assuming that increased resources will inherently resolve the performance issues. Option B. Initiate a complete rewrite of the application's core business logic in a newer technology stack, without a detailed analysis of the current application's specific performance issues. Option C. Conduct a comprehensive performance profiling of the application and its underlying database interactions, focusing on identifying slow queries, inefficient PL/SQL code, and excessive network traffic, then implement targeted optimizations based on this data. Option D. Implement a broad set of caching mechanisms across all data retrieval points in the application, without first identifying which specific data access patterns are contributing most to the performance degradation. The correct answer is C. Conduct a comprehensive performance profiling of the application and its underlying database interactions, focusing on identifying slow queries, inefficient PL/SQL code, and excessive network traffic, then implement targeted optimizations based on this data. Explanation: the efficiency study reveals that the oracle9i Forms application, critical for processing customer orders, is experiencing significant performance degradation during peak hours. This degradation directly impacts order fulfillment times and customer satisfaction, posing a business risk. The challenge lies in identifying the root cause of this performance issue and implementing a solution without disrupting ongoing business operations or violating any established development or deployment guidelines. The chosen approach must consider the impact on the overall application architecture, data integrity, and user experience, all within the context of the oracle9i Forms development environment. The correct approach involves a systematic, data-driven investigation of the application's performance bottlenecks. This includes analyzing application logs, database performance metrics, and network traffic to pinpoint specific areas of inefficiency. Implementing targeted optimizations, such as query tuning, form redesign for reduced data retrieval, or judicious use of caching mechanisms, represents best professional practice. This aligns with the principles of building robust and efficient internet applications, ensuring that the application remains performant and reliable under varying load conditions. The focus is on understanding the system's behavior and making informed, incremental improvements. An incorrect approach would be to immediately implement drastic, untested changes without a thorough understanding of the underlying issues. For instance, randomly increasing database server resources without identifying the specific queries or processes causing the load is a wasteful and potentially destabilizing action. This fails to address the root cause and could lead to unnecessary costs and unforeseen side effects. Another incorrect approach is to prematurely rewrite significant portions of the application logic without a clear performance target or a comprehensive impact assessment. This introduces a high risk of introducing new bugs, increasing development time, and potentially deviating from the original functional requirements, all of which are professionally unacceptable. Professionals should employ a structured problem-solving methodology. This involves clearly defining the problem, gathering relevant data, formulating hypotheses, testing those hypotheses through controlled experiments, and implementing solutions based on evidence. Continuous monitoring and validation are crucial to ensure that the implemented changes have the desired effect and do not introduce new issues. This iterative process, grounded in analysis and testing, is essential for maintaining application integrity and achieving optimal performance. Question 10. Implementation of a new real-time data validation feature within an existing oracle9i Forms internet application requires careful consideration of its potential effects on the overall system. Which approach best ensures the integrity and performance of the application? Option A. Implement the feature using the latest available Oracle Forms patches without verifying compatibility with the current application version or assessing its impact on existing functionalities. Option B. Develop the new feature in isolation, focusing solely on its functional requirements, and assume it will integrate seamlessly with the existing oracle9i Forms application without further testing. Option C. Immediately integrate the new feature into the live application to allow users to benefit from the real-time validation as soon as possible, addressing any issues that arise post-deployment. Option D. Conduct a comprehensive impact assessment, analyzing dependencies, performance implications, security considerations, and potential conflicts with existing Forms modules and database interactions before proceeding with development and deployment. The correct answer is D. Conduct a comprehensive impact assessment, analyzing dependencies, performance implications, security considerations, and potential conflicts with existing Forms modules and database interactions before proceeding with development and deployment. Explanation: the scenario presents a common challenge in application development, integrating new features that might impact existing functionality and performance. The professional challenge lies in balancing the desire for innovation and enhanced user experience with the imperative to maintain system stability, security, and compliance with established development standards. Careful judgment is required to anticipate potential conflicts and unintended consequences before they manifest in a production environment. The correct approach represents best professional practice, because it systematically addresses the potential impact of the new feature. By conducting a thorough impact assessment, developers can identify dependencies, potential performance bottlenecks, security vulnerabilities, and conflicts with existing code or data structures. This proactive methodology aligns with the principles of robust software engineering, emphasizing risk mitigation and quality assurance. Specifically, in the context of oracle9i forms development for Internet applications, this involves understanding how the new feature interacts with the form's runtime, the database, and the web listener, ensuring that performance degradation or security breaches are avoided. Adhering to established Oracle development guidelines and best practices for forms applications is implicitly part of this assessment. An incorrect approach that involves immediate deployment without prior assessment represents a significant regulatory and ethical failure. It disregards the fundamental responsibility to deliver reliable and secure applications. This failure can lead to system downtime, data corruption, security breaches, and reputational damage, all of which can have severe business and legal repercussions. Furthermore, it violates the implicit contract with users and stakeholders to provide a stable and functional application. Another incorrect approach, focusing solely on the functional requirements of the new feature while ignoring its integration with the existing system, is also professionally unacceptable. This narrow focus can lead to unforeseen issues that are far more costly and time-consuming to resolve post-deployment. It demonstrates a lack of foresight and a failure to consider the holistic impact of development changes. The professional reasoning process for similar situations should involve a structured approach to change management. This begins with a clear understanding of the proposed change and its objectives. Next, a comprehensive impact assessment should be performed, considering technical, functional, performance, security, and user experience aspects. This assessment should involve relevant stakeholders, including developers, testers, database administrators, and business analysts. Based on the assessment, a plan for implementation, testing, and rollback should be developed. Continuous monitoring and feedback loops are crucial throughout the development and deployment lifecycle. Question 11. Quality control measures reveal a significant performance degradation in a critical Internet application developed using Oracle Forms 9i, impacting user response times during peak operational hours. The development team is under pressure to resolve this issue promptly. Which of the following represents the most professional and effective approach to addressing this performance bottleneck? Option A. Instruct the development team to implement a series of ad hoc code changes across various form modules, hoping that one of them will inadvertently improve performance. Option B. Conduct a thorough impact assessment to identify the root cause of the performance degradation, and then design and implement a targeted solution based on the findings. Option C. Immediately apply a widely available third-party performance enhancement tool to the application server, assuming it will resolve the issue without further investigation. Option D. Advise management to schedule a complete application rewrite in a newer technology, as Oracle Forms 9i is inherently incapable of handling current user loads. The correct answer is B. Conduct a thorough impact assessment to identify the root cause of the performance degradation, and then design and implement a targeted solution based on the findings. Explanation. Scenario analysis. This scenario presents a professional challenge because the development team has identified a potential performance bottleneck in a critical Internet application built using Oracle Forms 9i. Challenge lies in determining the most effective and compliant method to address this issue without introducing new risks or violating established development and deployment guidelines. The pressure to resolve performance issues quickly, coupled with the need to maintain application integrity and adhere to the specific constraints of the 1Z0-141 Oracle 9i Forms developer build Internet applications framework, requires careful judgment. The team must balance immediate fixes with long-term maintainability and adherence to the Oracle Forms 9i development paradigm. Correct approach analysis. The correct approach involves a systematic impact assessment of the identified performance bottleneck. This means thoroughly analyzing the root cause of the performance issue within the existing Oracle Forms 9i application architecture. This includes examining PL/SQL code, form module logic, database interactions, and network latency. The assessment should quantify the impact of the bottleneck on user experience and system resources. Based on this analysis, a targeted solution can be designed and implemented, such as optimizing SQL queries, refactoring inefficient PL/SQL blocks, or adjusting form configurations. This approach represents best professional practice because it is data-driven, minimizes unintended consequences, and ensures that changes are aligned with the principles of robust application development. Within the Oracle Forms 9i environment, it prioritizes understanding the problem before applying a solution, which is a cornerstone of effective software engineering, and aligns with the implicit guidelines for building reliable Internet applications as expected in the 1Z0-141 curriculum. Incorrect approaches analysis. Implementing a quick fix without a thorough impact assessment is professionally unacceptable. This approach risks introducing new bugs, exacerbating existing performance problems, or causing system instability. It bypasses the critical step of understanding the root cause, leading to superficial solutions that do not address the underlying issue. This violates the principle of responsible development and can lead to increased technical debt. Ignoring the performance bottleneck and hoping it resolves itself is also professionally unacceptable. This demonstrates a lack of diligence and a failure to uphold the responsibility of maintaining application quality. Performance issues, if left unaddressed, can degrade user experience, impact business operations, and eventually lead to more significant and costly problems. This approach neglects the proactive maintenance expected of a professional developer. Relying solely on external tools or patches without understanding their integration with the Oracle Forms 9i application is professionally unsound. While external tools can be helpful, their application must be guided by an understanding of the specific architecture and potential interactions with the existing codebase. Without an impact assessment, the introduction of such tools could lead to compatibility issues or unforeseen side effects, undermining the stability of the application. Professional reasoning. Professionals should approach performance issues by first establishing a clear understanding of the problem through a comprehensive impact assessment. This involves defining the scope of the issue, identifying its root cause, and quantifying its effects. Once the problem is understood, potential solutions can be evaluated based on their effectiveness, feasibility, and potential risks. The chosen solution should then be implemented with rigorous testing and validation to ensure it resolves the issue without introducing new problems. This systematic, analytical, and risk-aware approach is crucial for building and maintaining high-quality Internet applications, especially within the specific technological context of Oracle Forms 9i. Question 12. The performance metrics show a consistent degradation in response times for a critical Oracle 9i Forms Internet application during peak usage hours, impacting user productivity. The development team has identified a potential area for optimization within a frequently executed PL/SQL block. What is the most professional and responsible course of action to address this performance issue? Option A. Conduct a thorough performance analysis, including profiling the PL/SQL block, assessing the impact of potential changes on other application components, and developing a comprehensive test plan before implementing any modifications in a staging environment. Option B. Immediately revert the application to a previous stable version, assuming the recent code changes are the cause, and postpone performance tuning until a later date. Option C. Implement the identified PL/SQL optimization directly in the production environment during a scheduled maintenance window after a brief internal review. Option D. Escalate the issue to senior management, requesting additional resources for a complete application rewrite, as performance tuning is deemed too time-consuming. Correct answer is C. Implement the identified PL/SQL optimization directly in the production environment during a scheduled maintenance window after a brief internal review. Explanation. This scenario presents a professional challenge because the development team has identified a potential performance bottleneck in an Oracle 9i Forms application that is critical for business operations. The challenge lies in balancing the need for immediate resolution with the potential impact of changes on application stability and user experience. The development team must make a judgment call on how to address the performance issue without introducing new problems or violating established development and deployment guidelines. The correct approach represents best professional practice because it prioritizes a systematic and controlled method for addressing performance issues. This involves thorough analysis, impact assessment, and phased implementation with rigorous testing. This aligns with professional software development principles that emphasize quality, reliability, and minimizing risk. Specifically, in the context of oracle9i forms development for Internet applications, adherence to Oracle's recommended development lifecycle and best practices for performance tuning is paramount. This ensures that changes are well documented, tested in a representative environment, and deployed with minimal disruption. An incorrect approach that involves immediately deploying a quick fix without proper testing or impact assessment represents a significant regulatory and ethical failure. This could lead to application instability, data corruption, or security vulnerabilities, all of which can have severe business consequences and potentially violate service-level agreements or internal compliance policies. Another incorrect approach, such as ignoring the performance issue due to perceived complexity, is also professionally unacceptable. This demonstrates a lack of diligence and a failure to uphold the responsibility to maintain application performance and user satisfaction. Furthermore, making changes without consulting relevant stakeholders or adhering to change management procedures violates established governance and control frameworks, which are often implicitly or explicitly mandated by organizational policies and industry standards for application development and maintenance. Professionals should employ a structured decision-making process when faced with performance issues. This involves 1. Acknowledging and documenting the reported issue. 2. Conducting a preliminary investigation to understand the scope and potential causes. 3. Performing a detailed impact assessment, considering all affected modules, user groups, and downstream systems. 4. Evaluating potential solutions, weighing their effectiveness, risks, and implementation effort. 5. Developing a phased implementation plan with rollback strategies. 6. Obtaining necessary approvals and communicating the plan to stakeholders. 7. Implementing the solution in a controlled manner, followed by comprehensive testing and monitoring. Question 13. Risk assessment procedures indicate that a new user authentication module is to be integrated into an existing oracle9i forms Internet application. This module is designed to enhance security by implementing multi-factor authentication. What is the most appropriate approach to ensure the successful and compliant integration of this critical feature? Option A. Deploy the new module to a limited set of users for initial feedback before a full rollout, relying on their observations to identify issues. Option B. Prioritize rapid deployment of the new module to meet project deadlines, addressing any identified issues post-implementation as they arise. Option C. Conduct a comprehensive impact assessment that analyzes the proposed module's interaction with existing forms, database objects, and potential performance implications, followed by rigorous testing. Option D. Proceed with the integration based on the developer's understanding of the new module's code, assuming minimal disruption to the current application. The correct answer is C. Conduct a comprehensive impact assessment that analyzes the proposed module's interaction with existing forms, database objects, and potential performance implications, followed by rigorous testing. Explanation. Scenario analysis. The scenario presents a common challenge in Internet application development, integrating a new, potentially impactful feature without fully understanding its downstream effects on existing functionality and user experience. The professional challenge lies in balancing innovation and speed to market with the imperative to maintain system stability, data integrity, and compliance with established development standards. The oracle9i forms developer context implies a mature, potentially legacy system where changes can have cascading and unforeseen consequences. The impact assessment topic requires developers to proactively identify and mitigate risks before implementation. Correct approach analysis. The correct approach involves a structured and comprehensive impact assessment. This aligns with best professional practices in software development, emphasizing a proactive, risk-averse methodology. Specifically, it involves 1. Thoroughly documenting the proposed feature's requirements and intended functionality. 2. Analyzing how this feature interacts with existing forms modules, database triggers, stored procedures, and data structures. 3. Identifying potential conflicts, performance degradations, security vulnerabilities, and data integrity issues. 4. Developing test cases to validate the feature and its impact on the entire application. 5. Obtaining sign-off from relevant stakeholders, e.g., business analysts, project managers, based on the assessment findings. This systematic process ensures that potential problems are identified and addressed early, minimizing costly rework, system downtime, and reputational damage. It reflects a commitment to quality and responsible development, which are implicitly expected within the professional standards of Oracle development. Incorrect approach is analysis. Implementing the feature without a formal impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for established development life cycles and risk management principles. One incorrect approach is to proceed with implementation based solely on the developer's understanding of the immediate code changes. This ignores the interconnectedness of application components and the potential for unintended side effects. This failure violates the implicit ethical obligation to deliver robust and reliable software and could lead to data corruption or system instability, impacting users and the business. Another incorrect approach is to rely on informal testing by a limited number of users after deployment. This is reactive rather than proactive and exposes the production environment to unnecessary risk. It fails to meet professional standards of due diligence and can result in significant business disruption and financial loss, potentially violating service-level agreements or internal quality standards. A third incorrect approach is to prioritize speed of delivery over thoroughness, assuming that any issues will be minor and easily fixed. This demonstrates a lack of professional responsibility and a failure to appreciate the potential severity of unforeseen bugs in a production system. It can lead to a cascade of problems, erode user trust, and incur substantial costs for emergency fixes. Professional reasoning. Professionals should adopt a structured, risk-based approach to software development. When faced with implementing new features, especially in established systems, the decision-making process should involve 1. Understanding the scope and potential impact of the change. 2. Consulting established project documentation and development guidelines. 3. Performing a detailed impact analysis involving relevant team members and stakeholders. 4. Prioritizing risk mitigation strategies. 5. Documenting all findings and decisions. This methodical approach ensures that development efforts are aligned with business objectives, technical constraints, and quality standards, fostering a culture of accountability and continuous improvement. Question 14. Investigation of the potential ramifications of introducing a new reporting module into an existing Oracle Forms Internet application, focusing on its impact on user workflows, system performance, and data integrity, requires a structured and comprehensive evaluation process. Which of the following approaches best represents a professional and effective method for conducting this impact assessment? Option A. Conducting a detailed analysis of the new module's code, database interactions, and potential performance bottlenecks, followed by the development of a comprehensive testing plan that includes unit, integration, and user acceptance testing, and documenting all findings and mitigation strategies. Option B. Focusing the assessment primarily on the technical feasibility of integrating the new module, assuming that user experience and performance will naturally align with the technical implementation. Option C. Implementing the new reporting module directly into the production environment, and then addressing any reported issues or performance degradations as they arise through ad hoc fixes. Option D. Performing a quick review of the new module's code by a senior developer, and then relying on informal feedback from a few key users during a limited pilot phase to gauge its reception. The correct answer is A. Conducting a detailed analysis of the new module's code, database interactions, and potential performance bottlenecks, followed by the development of a comprehensive testing plan that includes unit, integration, and user acceptance testing, and documenting all findings and mitigation strategies. Explanation. Scenario analysis. This scenario presents a professional challenge related to the impact assessment of a new feature in an Oracle Forms application. The challenge lies in ensuring that the assessment is thorough, accurate, and considers all potential ramifications without introducing bias or overlooking critical dependencies. The developer must balance the desire for rapid deployment with the necessity of robust testing and user impact evaluation, all within the context of the 1Z0-141 oracle9i Forms developer. Build Internet Applications curriculums implied best practices for application development and deployment. Need to consider user experience, performance, and potential integration issues with existing systems makes a superficial assessment professionally risky. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment that begins with understanding the proposed feature's functionality and its intended users. This includes analyzing how the new feature interacts with existing data structures, business logic, and user interfaces. A key element is identifying potential performance bottlenecks that might arise from the new code or data access patterns. Furthermore, a thorough assessment necessitates defining clear testing strategies, including unit, integration, and user acceptance testing, to validate the feature's correctness and usability. Documenting the assessment findings and proposed mitigation strategies is crucial for transparency and accountability. This approach aligns with professional software development principles of quality assurance and risk management, ensuring that the deployed application remains stable and meets user needs. Incorrect approaches analysis. One incorrect approach focuses solely on the technical implementation of the new feature, neglecting to consider its broader impact on end users or system performance. Its failure to assess user experience and potential performance degradation represents a significant ethical and professional lapse, as it prioritizes code completion over application usability and stability. Another incorrect approach involves relying on anecdotal feedback from a limited group of users without a structured testing plan. This is professionally unsound because it lacks objectivity and may not uncover systemic issues affecting the wider user base. It also fails to adhere to best practices in quality assurance, potentially leading to the deployment of a flawed feature. A third incorrect approach, which involves deferring the impact assessment until after the feature has been deployed, is a critical failure in risk management. This reactive stance can lead to significant disruption, data corruption, or security vulnerabilities, all of which are professionally unacceptable and could have severe consequences for the organization and its users. Professional reasoning. Professionals should approach impact assessments by first establishing a clear understanding of the project's scope and objectives. They should then develop a structured methodology that includes identifying all stakeholders, defining assessment criteria, and outlining testing and validation procedures. A critical step is to proactively identify potential risks and develop mitigation plans. Documentation throughout the process is essential for tracking progress, communicating findings, and ensuring accountability. When faced with uncertainty, professionals should err on the side of caution, conducting more thorough assessments rather than fewer. This systematic and proactive approach minimizes the likelihood of unforeseen problems and ensures the delivery of high-quality, reliable applications. Question 15. What factors determine the effectiveness of an impact assessment when modifying existing oracle9i forms internet applications, considering potential performance degradation and security vulnerabilities? Option A. The speed at which developers can implement the modifications, prioritizing rapid deployment over detailed analysis. Option B. The number of new features added to the application, regardless of their complexity or interaction with existing modules. Option C. The thoroughness of evaluating how proposed changes affect database interactions, PL/SQL logic, and client-server communication, alongside a review of security implications for data access and user authentication. Option D. The personal experience of the lead developer with previous Oracle Forms projects, without formal documentation or testing. The correct answer is C. The thoroughness of evaluating how proposed changes affect database interactions, PL/SQL logic, and client-server communication, alongside a review of security implications for data access and user authentication. Explanation. The scenario of developing internet applications using Oracle Forms 9i, particularly concerning impact assessment, presents a professional challenge due to the need to balance technical feasibility, user experience, and adherence to established development practices within the context of the oracle9i Forms developer framework. The challenge lies in anticipating and mitigating potential negative consequences of design choices or implementation strategies before they manifest in the deployed application, which could lead to performance issues, security vulnerabilities, or user dissatisfaction. The correct approach to impact assessment in this context involves a systematic evaluation of how proposed changes or features will affect the existing application's performance, security, usability, and maintainability. This includes considering the oracle9i Forms environment-specific characteristics, such as its client-server architecture, PL/SQL integration, and database interaction patterns. Best professional practice dictates a proactive, iterative assessment process that involves stakeholders, leverages testing, and prioritizes potential risks. This aligns with general software development best practices that emphasize risk management and quality assurance, ensuring that the application remains robust and meets its objectives without introducing unforeseen problems. An incorrect approach would be to neglect thorough impact assessment, assuming that minor changes will have negligible effects. Failure to consider the interconnectedness of application components within the oracle9i Forms environment can lead to significant performance degradation, especially under load, or introduce security loopholes if data handling or user authentication mechanisms are not carefully reviewed. Another incorrect approach is to focus solely on functional requirements without considering non-functional aspects like performance and scalability. This can result in an application that technically works but is unusable in a real-world scenario. A third incorrect approach is to rely on ad hoc testing or intuition rather than a structured impact assessment methodology. This increases the likelihood of overlooking critical issues that a systematic review would uncover. Professionals should employ a decision-making framework that begins with clearly defining the scope of the impact assessment. This involves identifying what aspects of the application are likely to be affected by a proposed change. Next, potential impacts should be brainstormed and categorized, e.g., performance, security, usability. For each potential impact, its likelihood and severity should be estimated. Mitigation strategies should then be developed for high-priority risks. Finally, the assessment should be documented and communicated to relevant stakeholders, and the effectiveness of mitigation strategies should be verified through testing. Question 16. When evaluating the most appropriate method for maintaining user-specific data across multiple form navigations in an Oracle Forms 9i Internet application, which approach best balances security, performance, and maintainability without requiring complex server-side session management or exposing sensitive information to the client? Option A. Store all user session data, including sensitive credentials and transaction details, in client-side hidden text items within the form. Option B. Implement a custom server-side caching mechanism using PL/SQL packages to store all user-specific data, relying on the server to manage session state entirely. Option C. Utilize form parameters and global variables within Oracle Forms to store and retrieve transient user-specific data that does not require high security. Option D. Pass all necessary user data as URL parameters with each subsequent form request to maintain context. Correct answer is C. Utilize form parameters and global variables within Oracle Forms to store and retrieve transient user-specific data that does not require high security. Explanation. The scenario presents a common challenge for Oracle Forms developers: managing user session state in a web-based internet application built with Oracle Forms 9i. The core difficulty lies in balancing the need for a responsive user experience, which often implies maintaining some state between requests, with the inherent stateless nature of HTTP and the potential security and resource implications of poorly managed session data. Developers must adhere to best practices for web application development, ensuring that sensitive information is not inadvertently exposed and that the application scales efficiently. The correct approach involves leveraging Oracle Forms' built-in mechanisms for managing client-side state, such as form parameters and global variables, in conjunction with careful consideration of how data is passed between the client and server. This method is professionally sound because it aligns with the architectural principles of Oracle Forms 9i Internet applications, minimizing server-side overhead and reducing the risk of security vulnerabilities associated with storing excessive or sensitive data on the client. It also promotes a cleaner separation of concerns, where client-specific state is managed on the client, and server-side logic remains focused on data processing and business rules. This approach is consistent with the general principles of secure and efficient web application development, even within the specific context of Oracle Forms 9i. An incorrect approach might involve storing sensitive user credentials or large amounts of transactional data directly in client-side hidden fields or JavaScript variables without proper encryption or validation. This is professionally unacceptable because it creates significant security risks, making the application vulnerable to cross-site scripting (XSS) attacks and data tampering. Another incorrect approach could be to rely heavily on server-side session objects without a clear strategy for managing their lifecycle, leading to potential memory leaks, performance degradation, and increased server load, especially under high user concurrency. This violates the principle of efficient resource utilization and can impact the overall stability and scalability of the application. A third incorrect approach might be to pass all necessary data back and forth between the client and server for every user interaction, even for small pieces of information. While seemingly secure, this can lead to a poor user experience due to increased latency and can place an unnecessary burden on network resources and server processing. Professionals should approach such situations by first understanding the specific requirements for state management within the application. They should then evaluate the available tools and techniques within the Oracle Forms9i framework, prioritizing solutions that offer a balance of performance, security, and maintainability. A thorough risk assessment should be conducted for any approach that involves storing data on the client or managing server-side sessions. The decision-making process should be guided by the principles of least privilege, data minimization, and efficient resource allocation, ensuring that the chosen solution aligns with both functional requirements and security best practices. Question 17. Cost-benefit analysis shows that implementing a new feature to capture user preferences in an oracle9i Forms internet application offers significant potential for personalized user experiences and future marketing opportunities. However, the development team is under pressure to deploy this feature within a very tight deadline, and the proposed implementation involves direct database manipulation for storing these preferences without extensive validation or a rollback strategy. What is the most professionally responsible approach to proceed? Option A. Implement only client-side JavaScript validation for user preferences, as this is faster to develop and deploy, and assume the database will handle any remaining data inconsistencies. Option B. Postpone the feature development until a later release when more time is available for thorough testing and a more robust implementation, even if it means missing the current deadline. Option C. Implement the feature with robust server-side PL/SQL validation and comprehensive unit and integration testing, followed by a phased rollout to a subset of users to monitor for issues before full deployment. Option D. Deploy the feature immediately as designed, relying on user input to correct any data anomalies that may arise to meet the urgent business requirement. The correct answer is C. Implement the feature with robust server-side PL/SQL validation and comprehensive unit and integration testing, followed by a phased rollout to a subset of users to monitor for issues before full deployment. Explanation. The scenario presents a common challenge in internet application development, balancing the need for rapid feature deployment with the imperative of maintaining data integrity and security, especially when dealing with sensitive user information. The oracle9i Forms developer context implies a specific technological environment and associated best practices prevalent during that era, which often emphasized robust data handling and adherence to established development lifecycles. The professional challenge lies in navigating the trade-offs between expediency and the long-term consequences of technical debt and potential security vulnerabilities. Correct approach, which involves a thorough impact assessment and a phased rollout with robust testing, represents best professional practice because it aligns with fundamental principles of software engineering and data governance. In the context of oracle9i Forms development, this would typically involve leveraging the built-in validation mechanisms, implementing server-side PL/SQL logic for complex business rules, and conducting comprehensive unit integration and user acceptance testing before full deployment. This methodical approach minimizes the risk of introducing defects that could compromise data accuracy or expose sensitive information, thereby upholding the implicit trust users place in the application. Adherence to established development methodologies, even in older technologies, is crucial for maintaining system stability and compliance with any applicable data protection guidelines of the time. An incorrect approach that prioritizes immediate deployment without adequate testing or validation mechanisms would represent a significant regulatory and ethical failure. Such an approach could lead to data corruption, unauthorized access, or breaches of user privacy, which, depending on the jurisdiction and the nature of the data, could have legal repercussions. For instance, if the application handled financial or personal identifiable information, a failure to implement proper security controls and validation could violate data protection laws. Ethically, it demonstrates a disregard for user well-being and the integrity of the system, potentially damaging the reputation of the development team and the organization. Another incorrect approach, such as relying solely on client-side validation, would be a failure because client-side validation is easily bypassed and does not provide the necessary security or data integrity guarantees required for robust Internet applications, especially in the context of oracle9i forms where server-side processing was paramount for security and business logic. The professional decision-making process for similar situations should involve a structured risk assessment. This includes identifying potential impacts on data integrity, security, user experience, and system performance. Developers should then evaluate different implementation strategies against these risks, considering the capabilities and limitations of the chosen technology stack, oracle9i forms in this case. Prioritizing solutions that offer a balance of functionality, security, and maintainability, and advocating for sufficient time for testing and quality assurance are hallmarks of professional responsibility. When faced with pressure for rapid deployment, professionals must be able to articulate the risks associated with shortcuts and propose alternative, more secure and reliable, albeit potentially slightly slower, development paths. Question 18. Operational review demonstrates that users of an Oracle Forms Internet application are experiencing significant delays when retrieving and displaying large datasets. The application interacts directly with an Oracle database. The development team has been tasked with improving the responsiveness of these data retrieval operations. Option A. Suggest a complete migration of the application from Oracle Forms to a modern web framework, citing the inherent limitations of older technologies. Option B. Analyze the SQL statements generated by Oracle Forms for data retrieval and optimize them for efficiency, potentially by rewriting queries or ensuring appropriate database indexes are in place. Option C. Recommend upgrading all user workstations to the latest hardware and increasing their internet bandwidth to mitigate perceived slowness. Option D. Implement a caching mechanism at the client-side browser level to store frequently accessed data, reducing the need for repeated database queries. Correct answer is B. Analyze the SQL statements generated by Oracle Forms for data retrieval and optimize them for efficiency, potentially by rewriting queries or ensuring appropriate database indexes are in place. Explanation. Scenario analysis. This scenario presents a common challenge in Internet application development where performance bottlenecks can arise from inefficient data retrieval. The developer must balance the need for rapid data access with the integrity and maintainability of the application's data layer. The professional challenge lies in identifying the root cause of the performance degradation and implementing a solution that is both effective and adheres to best practices for Oracle database interaction within the context of Oracle Forms. Correct approach analysis. The correct approach involves analyzing the SQL statements generated by Oracle Forms and optimizing them for better performance. This aligns with the principles of efficient database design and application development. Oracle Forms, when interacting with the database, generates SQL. Inefficiently written or poorly indexed SQL is a primary cause of slow application performance. Identifying and rewriting these SQL statements, or ensuring appropriate indexes exist on the underlying tables, directly addresses the performance issue at its source. This is best professional practice as it leads to a more responsive and scalable application, reducing user frustration and improving overall productivity. It also demonstrates a thorough understanding of how Oracle Forms interacts with the database, a key skill for an Oracle Forms developer. Incorrect approaches analysis. One incorrect approach would be to solely focus on client-side optimization, such as increasing client machine resources or tweaking browser settings. This fails to address the fundamental issue if the bottleneck is server-side database performance. It's a superficial fix that doesn't resolve the underlying problem and can lead to wasted resources. Ethically, it misrepresents the solution to the stakeholders, implying a fix that doesn't truly exist. Another incorrect approach would be to indiscriminately add indexes to all tables involved without proper analysis. While indexes can improve read performance, they also incur overhead for write operations, inserts, updates, deletes, and consume disk space. Adding unnecessary indexes can actually degrade overall performance and complicate database maintenance. This demonstrates a lack of analytical rigor and can lead to unintended negative consequences, violating professional due diligence. A further incorrect approach would be to suggest a complete re-architecture of the application to a different technology stack, without first exhausting optimization possibilities within the existing Oracle Forms environment. While re-architecture might be a long-term consideration, it's an extreme and costly solution for a performance issue that might be resolvable through targeted SQL tuning. This approach bypasses a systematic problem-solving process and can be seen as an unprofessional overreaction. Professional reasoning. Professionals should approach performance issues systematically. First, gather data to pinpoint the bottleneck. This involves monitoring application response times, database performance metrics, and analyzing the SQL being executed. Once the root cause is identified, evaluate potential solutions, considering their impact on performance, maintainability, and cost. Prioritize solutions that address the core problem directly and adhere to established best practices for the technology stack in use. Document the findings and the implemented solution for future reference and knowledge sharing. Question 19. The audit findings indicate that a custom Oracle Forms application, designed to display user-submitted comments on a public web page, is susceptible to cross-site scripting (XSS) attacks due to the way user input is rendered. The application directly incorporates the comment text into the HTML output without any sanitization or encoding. Which of the following approaches best mitigates this identified security vulnerability while adhering to the principles of secure Internet application development as expected for the 1Z0-141 exam? Option A. Implement a regular expression on the server to strip out all characters that are not alphanumeric, thereby preventing any script injection. Option B. Rely solely on client-side JavaScript validation within the comment submission form to filter out potentially malicious characters and scripts. Option C. Implement server-side validation to ensure the comment text adheres to predefined character sets and length limits, and then encode the comment text using HTML entity encoding before embedding it into the dynamic HTML output. Option D. Directly embed the raw user-submitted comment text into the HTML output to ensure that all original formatting and characters are preserved for the end user. Correct answer is C. Implement server-side validation to ensure the comment text adheres to predefined character sets and length limits, and then encode the comment text using HTML entity encoding before embedding it into the dynamic HTML output. Explanation. The audit findings indicate a potential security vulnerability in the application's handling of user input, specifically concerning the generation of dynamic HTML content. This scenario is professionally challenging because it requires the developer to balance functionality with robust security measures. The core issue lies in preventing cross-site scripting (XSS) attacks, where malicious scripts are injected into web pages viewed by other users. The 1Z0-141 oracle9i Forms developer Build Internet Applications exam emphasizes building secure and reliable Internet applications. And improper input validation and output encoding are common pitfalls. The correct approach represents best professional practice because it directly addresses the identified vulnerability by implementing appropriate security controls. Specifically, it involves sanitizing user-supplied data before it is incorporated into dynamic HTML content, and ensuring that any data displayed to users is properly encoded to prevent script execution. This aligns with general principles of secure coding and the implicit requirement within the exam scope to build applications that protect against common web vulnerabilities. The Oracle Forms environment, while older, still requires adherence to fundamental security principles when building Internet applications. An incorrect approach that involves directly embedding user input into HTML without any validation or encoding is professionally unacceptable. This failure constitutes a significant security risk, potentially exposing the application and its users to XSS attacks. Ethically, developers have a responsibility to protect users from harm, and this approach violates that duty. Another incorrect approach, which might involve relying solely on client-side JavaScript for validation, is also professionally flawed. While client-side validation offers a better user experience by providing immediate feedback, it is easily bypassed by malicious users. Server-side validation and encoding are essential for true security. Relying only on client-side measures would be a failure to implement adequate security controls, which is a breach of professional responsibility. The professional decision-making process for similar situations should involve a thorough understanding of the application's data flow, identifying all points where external data, interacts with the application's logic and presentation layers. Developers must then assess the potential risks associated with each interaction, prioritizing those that could lead to security vulnerabilities. Implementing a defense-in-depth strategy, which includes input validation, output encoding, and secure coding practices, is crucial. When in doubt, consulting security best practices and documentation relevant to the development environment is a hallmark of professional diligence. Question 20. The performance metrics show a consistent and significant increase in the average response time for key user transactions within the Oracle Forms Internet application, impacting the firm's trading desk operations. The application is built using Oracle Forms9i and deployed over the Internet. The development team has observed that this degradation is not correlated with peak user load or network congestion. What is the most appropriate initial course of action for the Forms developer to diagnose and resolve this performance issue? Option A. Analyze the execution plans of critical SQL statements executed by the Forms application and review the PL/SQL code for inefficient data retrieval or processing logic. Option B. Initiate a complete rewrite of the application's core PL/SQL modules to incorporate newer coding paradigms. Option C. Advise management that the performance issue is likely due to external network latency and requires no immediate application-level intervention. Option D. Immediately request an upgrade of the application server hardware to provide more CPU and memory resources. The correct answer is A. Analyze the execution plans of critical SQL statements executed by the Forms application and review the PL/SQL code for inefficient data retrieval or processing logic. Explanation. The performance metrics show a significant increase in response times for a critical Oracle Forms application used by a financial services firm. This scenario is professionally challenging because it directly impacts the firm's ability to serve its clients efficiently and could lead to financial losses or regulatory scrutiny if not addressed promptly and correctly. The developer must balance the need for immediate resolution with the long-term stability and maintainability of the application, all while adhering to the specific development guidelines and best practices relevant to Oracle Forms9i and Internet application deployment. The correct approach involves a systematic investigation of potential performance bottlenecks within the application's PL/SQL code, SQL queries, and Forms configuration. This includes analyzing the execution plans of frequently used SQL statements, identifying inefficient loops or data retrieval methods in PL/SQL, and reviewing form-specific performance tuning parameters. This approach represents best professional practice because it is data-driven, targets the root cause of the performance degradation, and aligns with the principles of robust application development and maintenance. It ensures that any fixes are targeted and do not introduce new issues, thereby maintaining application integrity and compliance with internal development standards. An incorrect approach of immediately increasing server resources, e.g., CPU, memory, without diagnosing the application's internal performance issues is professionally unacceptable. This is because it is a costly and potentially ineffective solution that masks underlying problems. It fails to address the root cause, leading to recurring performance issues and wasted resources. Ethically, it represents a failure to exercise due diligence and professional responsibility in diagnosing and resolving technical problems. Another incorrect approach of hastily rewriting large sections of PL/SQL code or SQL queries without thorough analysis and testing is also professionally unacceptable. This introduces a high risk of introducing new bugs, regressions, or even worse performance. It violates the principle of making informed, evidence-based changes and can lead to application instability. This approach demonstrates a lack of understanding of the impact of code changes and a disregard for the development lifecycle. A third incorrect approach of ignoring the performance metrics and attributing them to external network issues without any internal investigation is professionally irresponsible. This demonstrates a failure to take ownership of the application's performance and a lack of proactive problem solving. It can lead to significant client dissatisfaction and potential breaches of service-level agreements, which in a financial services context can have severe regulatory implications. The professional reasoning process for similar situations should involve 1. Acknowledging and prioritizing the reported issue. 2. Gathering all available diagnostic data, performance metrics, logs, user feedback. 3. Formulating hypotheses about the root cause. 4. Designing and executing targeted investigations to validate or invalidate hypotheses, starting with the application layer. 5. Implementing solutions based on confirmed root causes, followed by rigorous testing. 6. Monitoring the application post-fix to ensure sustained performance improvement.